Okay, thank you. Okay, thank you very much. And all right.
Yes.
Okay, thank you everyone for coming. I'm very excited to be here and to share with you from Wiwynn, our specifically OCP or the Open Compute Project and Project Olympus and our 19-inch solutions today. Now, in the context of, as we are all well aware of, the age of AI that has dawned upon us pretty much from, as we've seen, an explosive growth in this past year. Okay. So to begin, show of hands, anyone heard of Wiwynn? You guys heard of Wiwynn? Oh, great, yes, see a few people here, yes, great, that's fantastic. So for the rest, and also the people who've heard of us, I'll give a brief introduction. So we're mainly owned by Wistron Corporation, which is a huge ODM manufacturer in Taipei. And we were established about 6 years ago, so April 12, 2012. So our whole theme is really about being a value partner for our customers, and especially focusing on the cloud service business. So let's see how we do that. So we consolidated into a simple formula. So on the left-hand side, we have customer value, and that equals workload performance over total TCO. So really, we want to provide the highest workload performance as well as lowering our total TCO as much as possible, thereby really boosting our customer value. So how does that translate into our company mission? And we come up with a simple quote for that. So basically, it's straightforward. Provide the best TCO, workload optimized IT solutions for the data center. And here we want to emphasize that we are not just providing simple independent nodes or infrastructure, like let's say just a server directly to our customers. We are able and we go towards a direction of providing a total solution. So that means when we work with our customers, we provide a solution from a top-down perspective. Let's say the customer wants a storage-intensive infrastructure for their needs, or computing-intensive, or IO-intensive. So we will take our available products in our line and actually build a configuration and then provide it to the customer that's tailored to whatever their needs are. So we also have a global footprint. And coming here, you see we begin with our footprint in Taipei, Taiwan, which is where our headquarters are located, as well as we have various branch offices in Tokyo, Japan, for the first one, Shanghai, China, and as well as all the way on the west coast of the USA in San Francisco, kind of the heart of Silicon Valley. And we also have manufacturing sites all over to service our customers wherever they may be. For our US customers, we have a manufacturing site in Juarez, Mexico. And for our European customers in the Czech Republic. And we also have our valuable partner, Circle B, based in Amsterdam. And they'll be able to provide a local presence for our European customers. And as well as we have a large manufacturing site in Zhongshan, China. And they do a lot of, all the way from the L6 to L10 manufacturing levels for our cloud infrastructure. Having said that, let's begin a video, and you can see what's going on in our manufacturing sites. Okay. So as you can see here, this is actually our manufacturing site in Juarez, Mexico. And they're actually putting together various servers and also the rack for the Open Compute Project, namely the Open Rack version 2. And OCP, as if you guys are familiar, is an initiative driven by Facebook and really emphasizing certain tenets, namely like efficiency, scalability. And we also have our own in-house monitoring software, so our customers can actually log in anytime they want. It's 24 hours, and see the status of each node in the rack that's being tested. So you can see for yourself the progress of the rack that you guys will be purchasing, which is a very neat feature that we've had very positive feedback from our customers. And here is very interesting is also Project Olympus, which is, is part of Open Compute Project, but the initiative is driven by Microsoft. And you see they have their own rack. It's a white, and then here's the ORV2, which is all black. That's the differentiating factor you can see there. Wiwynn. So great, yeah, that gives you a good inside look at our manufacturing site. So with this picture, we want to come from a top-down perspective. As we know, in the age of AI-driven applications, it's evolved through many things. There's just so many different types of applications in the AI world. That variation from machine learning, deep learning. So with this new era of applications for AI, the infrastructure has changed accordingly as well. And this is where Wiwynn really comes in, because we are providing the fundamental layer of infrastructures for the data center and to run those applications. As well as the demands, these demands are kind of from the old age till now, it doesn't really change. So the fundamental demands for these various applications, such as computing, storage, these will always be there, and then that's how we optimize our infrastructure to really fulfill those demands. So Wiwynn, focusing on the cloud infrastructure, we can separate it into three main categories. The first one is our OCP infrastructure, and that's where we provide a various line of open compute servers and nodes. And as well as we have the Project Olympus nodes. And finally, the traditional 19-inch nodes infrastructure. And you can come to our booth. We actually have machines for each of those three categories laid out on our booth. So you can actually go and touch them and then open up, see if there are any needs. Like let's say you want a server with multiple sockets or however many drives for your NVMe flashes, such as that. So let's begin with the Open Compute Project's infrastructure that we've brought today to CloudFest. So the left-hand side is basically the emphasis of Open Compute Project idea that, because it's built out of a hyperscale kind of environment, that you can save power efficiency, which is one of the big things any data center consideration will focus on. So the first product that we have in our booth is the SV7220G3 over here, and over here, as you can see here. So this is utilizing the latest Intel next generation scalable processor. It's a 2U 3-node form factor, and it's great for your HPC needs. As well as similarly, we have another 4U, and this is a 16-node server, and it utilizes the Xeon D processor for each of those 16 servers. So here's what we offer in our computing. And we also have JBOD and JBOFs in the Open Compute Project infrastructure. So this is codenamed Lightning, but we call it ST7200. And this is a 2U. It can hold up to 30 U.2 NVMe drives or 60 M.2 NVMe drives based on the carrier that you want to select, so you can have two modes for that. And our latest new JBOD solution, the ST7000G2, this is a 4U 72 bay chassis, and it holds a 3.5-inch hard drives. So, and it's very, the interesting thing about it has 3 configurations. It can be configured basically as a pure JBOD, or it has slots for 2 microserver cards. So you can also have the second configuration with 1 microserver card, or finally the third configuration with 2 microserver cards. So it can act essentially as a JBOD or a storage server. So moving on to the Project Olympus, which is driven by Microsoft. Here's kind of the basic idea if you're not familiar yet. It's it comes out of Microsoft's hyperscale cloud environment where they want to design hardware specifically for the Azure cloud and their business needs. And they followed along with OCP, really embracing the idea of openness. And that's why in the Open Compute Project, you can find their own section specifically for Project Olympus. So that was kind of the second tenet they had in mind when they were creating this whole entire project. And finally, similarly to OCP, there's the industry ecosystem where they want to contribute to building this open ecosystem for the data center. Okay. And here, similarly, we have the products in our booth. And the SV5100G3, that is actually commercially available now, and it's quite recent, so that's a highlight. And this is a 1U, and it's also a server with a DDR4 memory, 24 DIMM slots. It has the latest redfish management compatibility, and also 3 PCIe by 16 full height half-length slots in the front. And another interesting thing that Microsoft or product that we, out of Project Olympus that we brought is the ST5100G3. So this has a very interesting design that you've probably seen at the Intel booth here today, at this event already, and which is the concept of the ruler SSD. So the unique thing about the ruler SSD is you can see this is kind of what they're pushing for the new kind of future of NVMe storage, or especially just form factor. They believe it will provide key efficiency or convenience benefits. Now, we also not only have the ruler support of ruler SSD, Intel's ruler SSD, but also we can have 4 M.2 in a ruler stick. So there's 2 configurations that the ST5100G3 can support. And finally, we have a hardware platform accelerator, and this is the XC200. It can connect up to 4 nodes, 4 hosts, and it's a 1U with 16 GPU, currently NVIDIA, or basically it's a PCIe Gen 3 interface. So you can have your NVIDIA GPUs and support it and run your various machine learning, deep learning applications. And finally, this is our software offering. So as you're well aware of, the data center has evolved to a software-defined era. So there's many considerations. So previously, without the software-defined data center, let's say you want to use a resource, then you're kind of confined to a specific node. And if things go wrong with that, the problem goes along with that node. But with the idea of disaggregation and composability in the data center, you could have your various array of racks, and on top of that, you can compose a virtual node. And this virtual node can draw from the available physical resources, and they can be in disaggregated locations. And thereby, this key feature, you can basically get what you need, exactly what you need for your use. So it limits the overutilization, or limits underutilization, and so you can use the most of your physical resources the most efficiently. So with this slide, an example, a big one now is just cloud service. We know with like AWS or Azure, various cloud services. So with this technology, it's called Intel Rack Scale Design. Wiwynn is working closely with them. And with Intel rack scale design, we're able to, let's say you want to run your Azure or AWS VMs, then you can create a virtual node, and you can indicate exactly, I want this much computing power, this much I/O throughput, this much storage capacity. And from there, it will create that virtual node, and you can install your VMs as you would normally on, let's say, if it was actually a physical node. And with this method, you can scale up dynamically, and you can optimize for your workload with this kind of ability. And with big data analytics, you have, we've seen the popular Hadoop or Spark and Docker. Similarly, you can also indicate how much computing power, I/O, or storage you need for your use cases for that. And finally, AI with Tensorflow and their Caffe2 and PyTorch, for examples. These would utilize a lot of computing power, especially for your GPU. So you could, for example, in RSD, you can specify, it's coming down, is GPU pooling, the concept of pooling. So you could have maybe 50 GPUs available, and you say, I want to have 20. But these GPUs may be located in different nodes. And RSD is able to create that virtual node utilizing the specific 20 GPUs you specified. So in this way, this is a really interesting movement forward of how the software-defined data center will evolve. And we have a live demo of Intel rack scale design, and with our own in-house custom-made software GUI called Cluster Manager. So you can actually see from the software all the way down to the hardware, which is a half rack. You can see the live demo. And so we welcome you and excited to welcome you to come check it out at our booth. Wiwynn. Here's a short video on Intel rack scale design and Cluster Manager. And you can take a look.
In the community of Open Compute Project, all the members are looking forward to embracing prosperity from sharing and synergy. For years, Wiwynn has been carrying out commitment as an OCP contributor, delivering best quality solutions and latest infrastructure technology in the spirit of open compute. Wiwynn achieves the highest level of IT workload optimization for today's data centers. Although modern development of cloud computing allows server virtualization on a physical node and resources, such as CPU, storage, and memory, this could fall short for some applications, while others are excessive in utilization. Some applications are more computation power hungry, while the others are in need of storage capacity. Hence, the demand to flexibly compose a node with extensible resources has grown to address the resource optimization. As a leading hardware provider and OCP solution provider, Wiwynn has been working closely with Intel to unlock infrastructure potential. Intel rack scale design is a logical architecture that enables scalable pooled resources and maximizes utilization. Simply put, Intel RSD unlocks resources from physical servers, creates virtual pools of resources, adds physical resources into pools if pools run out, applies resources to application workloads, composes resources, and reconfigures as requirements change. The pooling technology can extend to applications on other PCIe devices in the future. Wiwynn offers a series of products for OCP and 19-inch racks for Intel rack scale design integrated with Intel Xeon processors. Enjoy the best workload optimization and TCO for your data center.
Wiwynn.
Good, I hope you have a better idea of Intel rack scale design technology. And we also have commercially available products for the OCP and 19-inch versions. So that's good, okay? So yeah, in summary, we've seen how AI applications will drive cloud infrastructure evolution. And that's where Wiwynn is aiming to position ourselves right at the forefront in terms of pushing and driving that new frontier. And also, Wiwynn will be at OCP Summit next week, shortly. So there will be new advancements in the RSD technology I just mentioned, as well as new products in our OCP product line, our Project Olympus product line, and also our 19-inch product line. So if anyone is going, we'll be very excited and hope to see you guys all there. So thank you very much for attending my talk, and please come to our booth, and I hope you have a great rest of the time at this great event. Thank you very much.